When we journey to a far-off place, we travel not just in space, but also in time as we move into the future. Until about a century ago, scientists believed that space and time were entirely separate. Theoretical physicist Sean Carroll explains how Albert Einstein overturned that idea.
One of Einstein's great insights was that space and time are related to each other. Where you have space and you have time, Einstein says actually there's only one thing, which we call space-time. And then he says this space-time thing, it's not just the stage on which all the action plays out. It's an actor itself. Space-time can change, it can move, it can bend, and it can warp.
Einstein's theory of relativity states that space-time is like a flexible fabric. The objects embedded in it, the sun, planets, even us, warp that fabric. And a consequence of that warping is what we call gravity. The more massive the object, the more space-time is warped, and the greater the gravity. We feel gravity. The flexibility of space-time is harder to grasp on a gut level, but its effects are measurable. As Sean demonstrates, the greater the gravity, the more slowly time flows.
For example, if I were on the ground floor with a clock, a super accurate atomic clock, and a twin of mine was up on the top floor of a building with an equally accurate atomic clock, if we later on compared them, mine would have ticked off fewer seconds.
On the ground floor, Sean experiences slightly more gravity than his twin on the top floor. He also experiences slightly less time than his twin. The difference is tiny, but real. And there are practical applications.
For example, the GPS system, the Global Positioning System, that is a very, very precise set of clocks on satellites orbiting around the Earth. And that orbit is in a slightly different gravitational field than we are in down here. So the fact that time moves differently here on the surface of the Earth than in the satellite orbit is very, very important to getting the GPS to work correctly.
Time on a GPS satellite clock advances faster than a clock on Earth by about 38 microseconds per day, so the system's computers correct for that. Motion also affects our experience of space-time.
The best way to say it is just staying still means that you experience the most time that you can. Moving around and doing things means you experience less time.
Let's revisit Sean at the wheel of his car and his twin on a park bench.
If you move out on your car and then you come back, compared to the person who stayed behind, your clock that you took with you on that journey will have experienced a little bit less time than the one who stayed behind.
We normally move too slowly to notice the effect. But if Sean could drive near the speed of light, he could race across the United States and back again 1,000,000 times and experience less than a second of time, while the twin he left behind would endure hours of waiting for Sean's return. In other words, Sean would have traveled into the future compared to his twin. This means space travel may get tricky in years to come. The faster our spaceships, the greater the gravity fields we encounter, the further out of sync we may become with those we leave behind.